This video covers everything that we did in class on Monday, April 26th, or Tuesday, April 27th, depending on your period. We always want to start those notes with the date, 4-26, and today we were working on Unit 6, Lesson 5. There were some important parts of class today that were a review of last week's lesson. So if you're feeling at all stuck when you open up the Desmos for today, I do strongly recommend that you come to office hours. But in this video, I'm going to cover the new material that we learned, which is also kind of a review, but let's talk through it. On Desmos, which you should have open as you watch this video, we worked on two equations in Activity 1. On Activity 1, you'll see first, 10.1 equals t plus 7.2. Now remember that this letter t is called a variable. In other words, it's a mystery number. There is some number t that makes this equation true. When you see solve the equation, that means figure out what t has to be in order for something plus 7.2 to equal 10.1. Today, we talked about how we can use inverse operations to solve these equations. So ask yourself, what subtraction sentence, something minus something, would tell you the number that t must be equal to? I'm going to edit my t's a little bit so that they don't look like plus signs. What would that subtraction sentence be? Take a second to think that over. We know that we need to subtract our sum, 10.1, that is the sum in our original equation, by the addend, or the number that we're adding, that is known. In this case, it's 7.2. So we're taking our sum minus our addend, the number that we are adding that we know. And 10.1 minus 7.2 equals 2.9. Now, we have the solution to our equation. T equals 2.9. But here's the great news. There's an easy way for us to check our work. We can simply rewrite the equation 10.1 equals 2.9 this time because I replaced my t with 2.9 plus 7.2. And you might want to ask yourself, okay, is this true? Does 2.9 plus 7.2 equal 10.1? It does. So we know that we have the correct value for t. This is an example of using inverse operations. Inverse operations undo each other. So our first example of an inverse operation is addition and subtraction. And you might recognize this from the ratios unit. We're just learning it a little bit more formally as part of expressions and equations. So this addition example was, of course, part A on Desmos slide 11. We also had a part B. And part B looked like this, 0.07 equals 10m. Now at first, this might look a little scary. The first thing we want to do is just remind ourselves that 10m is the same thing as 10 times m. That's a helpful reminder. And you might recall, again, from that ratios unit, that we can use division to help us find a missing product. In this case, our missing product is M. So I want to divide, and I said missing product, I meant missing factor. I want to divide my product, 0.07, divided by my factor, which is 10, and that's going to give me my missing value M. 0.07 divided by 10 is simply 0.007. We're dividing by 10, so we just move the decimal place one to the left. So the solution to this equation is M equals 0.007. And again, just like over here, we got to check our work. Let's try it out. If M is in fact 0.07, then 10 times 0.007 should equal 0.07. Does it work? Well, yeah, if we're multiplying this number by 10, all we need to do is move the decimal place one to the right. And so our final answer is 0.07. That checks out. The other type of inverse operation, besides addition and subtraction, is, of course, multiplication and division. So we need to be able to use those inverse operations to solve equations, which just means to figure out what those mystery numbers need to be equal to.